Tonight, if you drift too far from shore while swimming, you can turn around. You can swim back. The water holds you, and the shore never moves. Now imagine the shore is a space station, and there is no water, and nothing holds you. This is the nightmare scenario every astronaut trains for and hopes never to face. What happens if you unclip or your tether fails and you start floating away from the only safe place for hundreds of miles? Let's find out what really happens and how NASA made sure it almost never does. Outside the International Space Station, there is no up, there is no down, there is only the station and everything else. An astronaut on a spacewalk moves by pulling along handrails clipped to safety tethers the entire time. 2 tethers usually. One is always attached while the other is repositioned. It sounds simple. It is anything but. Because in microgravity, even a small push sends you drifting. Reach for a tool, misjudge the angle, and your whole body rotates instead of your hand. Everything you do out there fights against instincts. Built for a planet with gravity, your brain expects weight. Space gives you none. So what happens if a tether fails? What if you push off a handrail just a little too hard and suddenly the station is shrinking behind you? You would not fall. There is no down to fall toward. You would simply keep moving at whatever speed you left the station, in a straight line, forever, unless something stopped you. That is the physics. Newton's first law playing out in the worst possible place. An object in motion stays in motion. In orbit with no air resistance, nothing slows you down. Nothing brings you back. NASA understood this danger before a single spacewalk ever happened. In the 1960s, during the Gemini program, astronaut Eugene Cernan nearly proved it the hard way. During Gemini 9A in 1966, Cernan attempted a spacewalk that pushed his suit and his body to the limit. He overheated. His visor fogged until he could barely see. He struggled just to move along the handholds his own hands could not find. He was tethered the entire time, and it still nearly ended in disaster. That mission taught NASA a hard lesson. Floating in space is never as simple as it looks. By the 1980s, NASA had built something specifically for the scenario you are imagining right now. It was called the MMU, the Manned Maneuvering Unit. Think of it as a jetpack, bolted to the back of a spacesuit with small nitrogen thrusters controlled by a joystick. In 1984, astronaut Bruce McCandless II strapped one on, unclipped from the Space Shuttle Challenger, and flew free. Completely untethered. Just him, the jetpack, and empty space between him and the ship. It remains one of the most quoted images in spaceflight history. A human being, alone, further from safety than anyone had ever been. But the MMU was retired after a few years. It was heavy, expensive, and after the 1986 Challenger disaster, NASA reevaluated the risk of untethered spacewalks entirely. It was simply too much danger for too little benefit. So what replaced it? Something smaller. Something meant only for emergencies. It's called SAFER, Simplified Aid for EVA Rescue. Every astronaut who performs a spacewalk today wears one, strapped to the bottom of their life support backpack. It looks unassuming, almost like an afterthought, but it holds small thrusters and enough propellant to stop a slow drift and fly an astronaut back to the station if the impossible happens and a tether fails. Here is the part that sounds almost too simple to be true. If you started drifting away, SAFER would not launch you home instantly. You would need to stay calm. You would pull a small trigger, and the device would stop your tumbling first, because a spinning astronaut cannot safely aim toward anything. Once stabilized, you would use the hand controller to slowly, carefully point yourself back toward the station and fire short thruster bursts to close the distance. Slowly, deliberately. Because in space, Oversteering a burn could send you drifting even faster in the wrong direction. Astronauts train for this exact scenario in massive pools on Earth, like NASA's Neutral Buoyancy Laboratory, where the water simulates weightlessness, closely enough to rehearse the panic and the procedure, long before it could ever happen for real. And here is the twist that makes this story almost unbelievable. In the entire history of human spaceflight, across NASA, Roscosmos, ESA, and JAXA missions, no astronaut has ever actually drifted away from a spacecraft and been lost. Not once, not during the space shuttle era, not during any ISS spacewalk. The system works because it was never really about the jetpack. It was about redundancy stacked on redundancy. 2 tethers instead of 1. Rigorous training before every excursion. A partner watching your every move from inside the station. Mission control tracking your vitals and position in real time. The jetpack was the very last layer of a plan built so no astronaut would ever need it. So why does this scenario still feel so terrifying, even knowing the numbers? Because it touches something deeper than statistics. It's the fear of being unreachable, not lost in the sense of not knowing where you are, but lost in the sense that nothing can come get you fast enough. Out there, if something goes wrong, there is no ambulance, there is no Coast Guard, there is only what you brought with you, and the calm of your own mind. That's really what this scenario reveals. Not a flaw in engineering, but a truth about survival itself. Preparation beats panic every time, but only if the preparation happened long before the crisis began. Back on Earth, you rarely think about this kind of isolation. You're always within reach of help, a phone call, a road, a stranger nearby. You have never had to calculate your own way back to safety using nothing but a small tank of nitrogen and your own steady hands. But astronauts have. And they trained for it so thoroughly that the scenario you are imagining right now has stayed exactly what it started as. A worst case, prepared for so completely that it has never had to become anything more. So tonight, when you walk from one room to another, or drive home without thinking twice about the distance, remember what that same simple act of getting back means for someone floating 300 miles above you. For you, the shore never moves. For them, the shore is only steady because someone made sure it always would be.